All right, here's continuation of properties of logarithms. Because you can multiply logarithms, you can also take powers of logarithms. So this is another property. And what happens is you can take that power p and bring it down in front. And then there's an example that follows in that box. So here's the property, and this is how you can use it. You can take that x and you can bring it down in front of the logarithm. So we have some examples here. So the first one says logarithm base 2 of 32 raised to the 6th power. So what we can do is we can take that 6 and bring it down in front. And then we can change that 32 to an exponential of the same base of 2. So 32 can be rewritten as 2 to the 5th power. Now we have an exponential logarithm of base 2. So they will cancel each other out. So we're just going to be left with a 5. And then we would multiply that times 6. So 6 times 5 is 30. Second example, this is the common log. Notice that the logarithm is missing its base, so it's assumed that is base 10. And then we have an exponential of that same base. So one thing we can do is we can notice that these are inverses of each other, or we can also bring that 4 down in front. So that's 4 in front times that logarithm base 10 of 10 to the 1st power. So these are inverses of each other. So we're going to be just left with the number 1. And we multiply it times 4, so 4 times 1 is 4. The last example on the slide, we have the exponent up here, so we can bring that down in front, so that 2 goes down in front. And then we have our logarithm of base 5, and then of 25. Just going to erase that pink number 2. So now we're going to focus on the green part, and we're going to change this 25 to an exponential. We want it to be the same base as our logarithm, so that's going to be 5 squared. And then we have the 2, and then logarithm of base 5. So notice the logarithm is base 5, the exponential is base 5, so we'll be just left with 2. And then that 2 out in front, so 2 times 2 is 4. All right, here's some more examples. So we're going to use our property. We're going to bring that 5 down in front. And then we have our logarithm of base 2 of 1/2. And I'm going to change this 1/2 to an exponential. So what you can do is you can use your negative exponent rule and you can flip it. So now it's going to make that a negative 1 exponent. We still have our 5 and then our logarithm of base 2. Now our logarithm is base 2, our exponential is base 2, they are inverses of each other, so we'll just be left with negative 1. And then we multiply that times 5, so 5 times negative 1 is negative 5. Next example, here's our exponent. We can bring that down in front. When you bring that down in front, you do want to create a parentheses because the entire x minus 5. And then we have our logarithm of base 5, and then that other 5 is still left raised to the 1st power. These two are inverses of each other, logarithm base 5, exponential base 5. So they cancel each other out. They are inverses of each other, so we're just left with the number 1. And then x minus 5. Now what we do is we would distribute that 1 to your binomial in the red, and you're just left with x minus 5. Next one, you can bring that -2 down in front, so the power down in front. Then we have our logarithm of 10. Now notice that that logarithm is missing its base. I'm going to just change that to base 10. That's called the common log. And then I have my exponent of 1. These two are inverses of each other, logarithm base 10, exponential base 10. So we're just left with our exponent value of 1, and then multiply that times -2. So we're left with -2. All right, our next slide shows you what we call the change of base formula. You use this formula so that you can use your calculator. So your calculator can do base 10, the common log, or base e, which we haven't gotten into quite yet, and that is another tool we'll be researching later on. So there's a couple examples here. We can change it to base 10, which is the most typical one, or any other base. So this is our formula right here for change of base. All right, so let's go ahead and show you how to use it. So right now our logarithm is base 9, and we can't use our calculator, and we might not be able to say if we wanted to do the inverse property. I'm going to try it. It's not going to work. I have a logarithm base 9, and I would say, okay, I want to take 27 and have the same base. 9 to the first is 9. 9 squared is 81. So that property of inverses isn't going to work. So instead, we use our formula, and we're going to change it to base 10. So how we do this is we're changing it to base 10, so I have a logarithm, and how I remember this number is higher, so it goes up on top. That's your numerator. And then this number is your subscript, so that's your denominator. That's just how I remember it. Then what we do is we enter this into our calculator. Please make sure you're careful here. These need to have parentheses when you divide. So then you would enter this into the calculator, and you get a value of 1.5. All right, the second example here. Again, we have a logarithm of base 8, and we can't change that 16 to be an exponential of base 8. So what we can do is we can change it to the common log using our change of base formula. So we have a logarithm, and then remember that 16 is higher, so that goes up in the numerator. And then our denominator is the subscript, so that goes in the denominator. And then you enter this into your calculator, and you get approximately 1.33.